Good morning, everyone. My name is Lloyd Green, and I am the Director, Engagement Marketing and Creative Community Services for the IEEE, and I will serve as the moderator for today's webinar. I'd like to welcome you all to the first in a series of webinars on the Internet of Things, conducted in partnership between the IEEE Standards Association and Micro Electromechanical Systems, MEMS. This webinar is focused on standards and testing MEMS and sensors. Our goal this morning is to provide you with a better understanding of why IoT, micro-electromechanical systems, and sensors need common specifications and standards, the role of interoperability in testing when it comes to IoT, what MEMS Industry Group, MIG, and IEEE are doing to facilitate IoT connectedness. We have assembled industry experts who will address several important topics pertaining to IoT and MEMS. Our first speaker will be Karen Lightman. As the Executive Director of the MEMS Industry Group, Karen manages the operations of MIG, spearheads strategic growth, and oversees sales, public relations, marketing, and outreach. Karen is active on the worldwide MEMS conference circuit as a keynote speaker and panelist, promoting MIG's role as a leading trade association advancing MEMS across global markets. In today's presentation, Carol will present on MEMS, sensors, and IoT, challenges, opportunities, and success. MEMS Industry Group's work on creating the IEEE 2700 standard and accelerated innovation community. Our second speaker will be Chuck Gritton. Chuck has held senior management positions at some of the world's largest communication companies. He is currently Chief Technology Officer at Hillcrest Labs, where he is responsible for all of Hillcrest Labs' technology development, including strategy, product architecture, and research. In today's presentation, Chuck will discuss test lab environments, why testing, specifications, and interoperability are crucial to advancing IoT technologies. Our third speaker will be Ken Faust, Platform Manager, Intel Corporation. Ken is a sensor technologist and researcher at Intel Corporation, where he's active in sensor and sense-making initiatives across Intel's product portfolio and R&D labs. In this capacity, he also works closely with the sensor industry and its consortiums, driving initiatives in sensor and I/O standardization. Today's Ken's presentation will address an integrator's perspective, how to ensure IoT products are introduced to the market and benefits end users. Our fourth and final speaker will be Ravi Subramaniam, Technical Director, IEEE Conformity Fostering. Ravi is responsible for establishing and supporting conformity assessment activities based on IEEE standards. Currently, he is focused on developing multiple programs in telecommunications, power and energy, cybersecurity, and imaging and sensor technologies. During Ravi's presentation, he will highlight why standards are relevant, open, and ensure the advancement of IoT technologies. All of our speakers' bios are available in full on the IEEE website. Now for a few housekeeping items. All participants' microphones will be on mute only. For any questions and answers or any assistance you may require, please use the chat box in your browser. This webinar is being recorded and will be posted to the IEEE website at the conclusion of the conference. With that being said, I'd like to welcome and introduce our first speaker, Karen Lightman.
Hi, everyone. This is Karen Lightman. I am the Executive Director of MEMS Industry Group. And Lloyd, thank you very much. I really appreciate you trying to say micro-electromechanical systems quickly. It's a hard one. So thank you, everyone, for joining me. And if you don't mind going to the next slide. Just want to introduce you to who MEMS Industry Group is. We've been around for 14 years. We are the only trade association in the universe, as I like to say, till we find life elsewhere, that is representing the MEMS and sensor supply chain. So you can see this little graphic of what that means. It means everybody that's involved in making, designing, creating, integrating, using MEMS, they are part of our membership. And the next slide will give you an idea of who we are. This slide actually, as of this morning, is already out of date because we have over 180 members and partners worldwide, and we're international. Next slide shows you our partners. I really think it's important to highlight some of our partners, especially IEEE, of course, because we cannot do the good work that we do without the partners that we have. Next slide, please. I just want to give you a quick plug for some events. We do conferences of our own as well as conferences worldwide. With MEMS Executive Europe is coming up in Copenhagen in a few weeks. The theme is maximizing the potential of MEMS and sensors. We will have speakers on the topic of the Internet of Things. We actually have several speakers and a panel. We have a technology showcase that demonstrates MEMS and sensors inside. We have market analysts. It is the creme de la creme. The movers and shakers of MEMS and sensors will be there, and I hope you can join me. Then we have our technical congress that will be in Cambridge, Massachusetts, and this is all about what we call co-creation. So it's collaboration, innovation, entrepreneurship, and this is where we roll up our sleeves and get together. Again, this is for members, but we invite you to consider joining us. It's a really awesome event. And next slide, I want to also plug our membership. We would not be who we are today if it weren't for our members. We actually have members who are celebrating 14 years, celebrating 10 years, and every year they re-up and join MEMS Industry Group. And I'm honored that the folks who were on today's webinar with me are members like Intel and Hillcrest, and IEEE is a partner. And we've got 180 plus more to list. I encourage you to check out our website. Hopefully that link will be somewhere, memsindustrygroup.org. And we really pride ourselves in being one of the only associations that helped create an industry out of a technology. We started in 2001. Man, have we come a long way. And that's what I want to talk about on our next slide, where hopefully you can see in the background, this is actually a gyroscope, a little image of a gyroscope that I got in the background here. And what MEMS stands for is, how Lloyd tried to say it earlier, is micro electromechanical systems. And how I like to describe it is that it's like a chip like an IC chip, but it has a moving component. So it's a miniaturized mechanical element. It's a device's structure, and also it's used to describe the way that something is manufactured. The manufacturing is very similar to semiconductor, and then it's basically at a micro scale, and it's everywhere. You don't realize it, but it's in your car. You probably have 50 MEMS sensors in your car. You have your iPhone. It goes portrait landscape. You get to play, I don't know, Angry Birds. It used to be the fun game. I don't know what is hip now, but that's all thanks to the MEMS inside your phone. It's about an $11 billion industry now. It's expected to double in the next few years, in 3 years. Holy cow. Definitely an investment in your time and energy. And as I mentioned earlier, it's everywhere, and it truly is the bedrock of what we call the Internet of Things. So next slide will show you graphically. Next slide, thank you, is showing you the top players. And this is thanks to our partners at Yole Development. And you'll see that it's hugely changed. So Robert Bosch and ST Micro are number 1 and 2. 5 years ago, the top 2 players were TI and HP. Definitely in the running, but look at Knowles, look at Canon, look at Denso, look at all these, look at InvenSense, the first fabless successful MEMS company. Analog Devices, it's a huge growing opportunity, definitely ripe for investment and for you to consider in your product offering. So next slide, please. We'll show you that growth. Next slide, thank you. So this is showing you we've had 12% growth historically, and that is expected to continue over the next few years. And you can see the consumer really helped bring that to life. You see the iPhone perhaps is part of that driver, and launched in 2007, and now they're ubiquitous. That wonderful word, that MEMS and sensors are truly everywhere, but they're not just in consumer. You're going to see them more in industrial applications and medical and health. And so the next slide what I want to talk about here is that, part of why our raison d'etre for having MEMS Industry Group is that we are about overcoming the remaining challenges to commercialization. And there definitely are some challenges. Standards I used to call the S word because people didn't want to talk about it. They considered standards their special sauce. But we've come a long way. We still have a ways to go. Interoperability is still a challenge. I just did a conference at CES on wearables. I've spoken at conferences like mHealth put on by our partner HIMSS. This issue of interoperability between devices, within devices, with the Apple iWatch coming, interoperability, this whole new world of Internet of Things. If we do not address the issues of standards and interoperability, there will not be an Internet of Things if we don't address. And then the last one is what I call the holy grail of challenges is power. And by power, what I'm talking about here is power management as well as energy harvesting and power creation. These are three huge things that we need to address. Standards, obviously, is what we're going to talk about today. Related to that is interoperability. And power, there's huge opportunity there. I'd like to, again, do a shout-out to MEMS Industry Group and our working group, especially our working group chair, Ken Faust, who will speak later today on the creation of the first ever MEMS standard for performance. It's the IEEE 2700. It is thanks to our working group and the work of our members that we created that in record time. We actually won an award for that from IEEE. I also want to point out we have something called the Accelerated Innovation Community. It's the first ever open source algorithm library. It's on our website as well. And then I want to do a shout out to some of our members who are doing great work in power management and energy harvesting. And then lastly, before I hand it off to my colleagues, I also want to point out that we have working groups that are meeting regularly and addressing these issues on standards testing as well as healthcare and tech transfer. Actually, I forgot to put that one in there. And then we have awesome partnerships who are helping us advance our work and address these challenges. All right, I hope we have time at the end for Q&A. I'm really excited to be here. And with that, I will take it on to our next speaker. Thank you.
Okay, thank you so much, Karen. That was a great presentation addressing the challenges and opportunities as it relates to MEMS. I'd like to remind all the participants that there is a hashtag that you can tweet. It's hashtag IEEE SAIOT, hashtag IEEE SAIOT. And our next speaker will be Chuck Gritton. Chuck, thank you so much, and we look forward to your presentation. Thank you.
Thanks, Lloyd. If we could go to the next slide, we can dive in. What we have here are the spec sheets from three major manufacturers of arguably the most important parameter of the oldest MEMS device in production. It was an accelerometer. And one of the key parameters of accelerometer is where the 0 point is, what differentiates plus readings from minus readings, how to take the sensor reading and know where gravity is, what the reading is relative to gravity. That's the zero gravity offset, or ZGO parameter. And you'd think that the most critical spec on the most common MEMS sensor would be the most standardized of them all. And in fact, they aren't, because you take these three reputable manufacturers, you'll notice there's no consistency at all on the specs. Bosch is very detailed, lots of specs that include the effects of aging and board mounting. But you go to ST, also a reputable manufacturer, they have one parameter, not as many as Bosch. And then you have Freescale that mentions a pre and post board mount parameter, but doesn't have as many parameters again as Bosch does. And so those three manufacturers don't have the same parameters. There's no consistency across the parameters. There are, in general, only typical values given, no mins, no maxes. And so from the point of view of a systems provider trying to standardize performance without mins and maxes and without consistency, that leads you to do your own data sheet. And but let me, before I dive into that, give you an example of the impact of this one parameter on performance. So if you could go to the next slide.
One of the common applications out there is to take a magnetometer reading and figure out where north is. And in order to do that, you have to know where the surface of the Earth is. And that means you have to know where gravity is, which direction it's pointing. But if you make an error, or if there is an error in the zero gravity offset, the ZGO parameter, even of 1 degree, which is far under the typical values that you see on these data sheets or that you get in real life, you can generate a lot of error on heading. Just 1 degree of pitch error can multiply to 2 degrees of heading error, even going up to 5 degrees, which is easily doable in the data sheets I showed you. You can get as much as 9 degrees of heading error. So your estimate of north can be 9 degrees off just from this one error alone. So just this one parameter can influence your error budget in the higher systems level processing. So next slide, please. So the thing is, the accelerometer is just one of many sensors you might want to consider. Gyroscopes, as Karen mentioned at the beginning, are also very common. They have a different set of parameters. There's proximity sensors, pressure sensors, etc. And for the accelerometer, the zero-G offset is hardly the only one. There are many, many others. And what you see across all these different sensors and all these different parameters is every supplier is treating the specification of those differently. They almost never have mins and vaxes. They almost never tell you what's going to happen when it's mounted on a board. They tell you when it's not mounted, as a rule. And they talk about the parameters and test them differently. So there's just no consistency here. And so next slide. With that, Hillcrest, our company is a sensor processing company, and so we want to tell our customers how the performance will behave, and we want to know how they're going to behave in real life. And so what we want to do is, given all this inconsistency out there, is actually generate data sheets ourselves. And so we have a whole sensor qualification lab where we run the parameters run these parts, hundreds of them, through a test procedure, and we generate standard criteria across all the different parts and a real-world data sheet so that we can decide not only what the typical is, but what the distribution is across all the parts and across all the parameters out there. So next slide. That's a lot of work to create that test lab, but the truth is we don't want to do that. We've spent a decade building that up, but if we had standards around naming, about definitions, around testing procedures and reporting, the truth is we wouldn't have to go to all that trouble. And we could focus more of our engineering resources on the value-adding software that's our real business and be able to add extra value that way through the sensor ecosystem. So we're a supporter of moving to stronger standards. Thanks.
Thank you so much, Ken. We really appreciate. Thank you, Chuck. We really appreciate that. Again, be part of the conversation. #IEEESAIoT. Our third speaker will be Ken Faust. Ken, thank you so much, and we welcome your presentation.
Great, thank you, Lloyd. Yeah, this is Ken Faust, a sensor technologist at Intel, and as Karen had alluded to, I chair the standards working group inside the MEMS industry group, as well as the sensor working group inside the MIPI Alliance, and the IEEE P2700. So I've been very fortunate over the last few years to apply the standardization passion to the industry, and the industry thankfully has been very responsive, which in turn continues to put inertia behind the effort. So today, what I'd like to take a few minutes to discuss is a little bit of an integrator's perspective and how standards promote scalability, which is something that as a system provider really requires. So if you were to rewind a few years ago, let's say 3 or so years ago, several of us that were working in the consumer space, in particular the mobile space, and we're looking to scale MEMS and sensor technology across our platforms, it was pretty easy for us to agree upon a problem statement. And the problem statement was, given the explosive adoption of sensor technologies in our devices and the variety of sensor types and vendors and the integration considerations, even as Chuck had mentioned, the variations in data sheets and product specs from devices, we acknowledged that we had a non-scalable integration challenge, and that was mostly due to the large number of sensor types, plus vendors, plus their product lines. This was making it very difficult to put reference platforms out there with a particular make and model of a sensor, and expect the adopters of that reference design to easily go from one vendor to the next or one part number to the next, which is very important for a growing industry. So this was a problem statement that many of us shared, and we turned to the MEMS industry group to be able to do something about that. And between the MEMS industry group and then later the IEEE, we were I think able to put a process in place that is helping us dramatically. Next slide, please. So, as I alluded to, we're taking action. The solution we came up with was to quickly unite key industry leaders, platform and vendors such as Intel or Qualcomm, as an example, OS providers, leading sensor vendors, MIG and MIPI Alliance members, to focus at that time on consumer electronics-based industry standards. There are standards available for MEMS and sensors. We felt that our category deserved a little attention, as they could be, the existing standards could be seen as heavy-handed even, and kind of out of touch with where consumer had gone. So through swift and targeted action, we set out to ratify new standards among the sensor industry vendors and leaders. So if we could agree that a standard was important and develop a document and agree to start following it, we felt the formalization of that could follow, but shortly after. But we could immediately start adopting these methods, and so we would quickly diffuse the standards into the industry and start adopting them. And so we were successful. In 2014, the IEEE released P2700, which was a standardized sensor performance parameters definitions. Our first effort. Some may say low-hanging fruit, but as Chuck had pointed out, we needed a guiding light for collateral with sensors, such that when you choose one sensor vendor and a customer wants to go to production with another, it could be more of a collateral review as opposed to hard physical validations. Granted, oftentimes are needed, but we were hoping that decisions such as sourcing could be made more quickly with better collateral. So our memorandum has been that adoption burden should be minimized and distributed, and that product differentiation and innovation must not be stifled. Let's no longer have standardization be the S word, because it's going to make it difficult for sensor vendors to continue to be successful. So what's happened and what started with the sensor performance parameter definitions, it has expanded. It's expanded into digital I/O for sensors, and I'll talk about this briefly on the next slide with the MIPI Alliance through the MIPI I3C SenseWire interface. It's expanding into test methods, so the performance parameter, the sensor performance parameter definitions standard has set a target for testing, and so that is having a trickle-down effect, and therefore there's an effort to start with the accelerometer and then move on to other sensors to standardize test methods. So I would like to pose a question then to the IoT world. How can we close standardization gaps for you? This has worked in consumer. We've worked quickly and can work efficiently, and would like to better understand what makes IoT different from consumer, and how we certainly have our thoughts and ideas, as were many of the same companies in that space. But I would really like to pose that question to the industry and work closely with you. Next slide, please. So as I mentioned, and the next big effort to hit is from the close relationship between MIPI Alliance members and MIG, or MEMS Industry Group members, and that's MIPI I3C SenseWire, which is a specific interface. You can see on the diagram on the left, highlighted in the red triangle, where it sits within all the other MIPI interfaces in the MIPI system diagram. But this will be released this year, and we set out with a goal to develop an I2C compatible interface. That's I2C, the popular two-wire interface sensors typically connect to, with sensor-focused differentiated features, reductions in power, pin count, and cost. It's very adaptable, flexible, and convenient. Things that were really gaps in I2C, which is a very mature interface. So it's been a great evolution of the interface, and we think a very good fit, not only for mobile but industries beyond mobile. Next slide, please. So as I touched on, we think we can serve IoT with an aggressive development timeline, really a model for the future. This is based on our past efforts, such as the standardized sensor performance parameter definitions. But we were literally able to go from project start to the industry starting to adopt. That is a document within the MEMS Industry Group that industry leaders had agreed was important, and agreed to start following in approximately 10 months. The additional 4 months after that was formalizing it in a form such as IEEE SA. But this is very exciting. I think conception to release in 10 months is aggressive, and something that many would welcome. Next slide. So in summary, technology integrators such as Intel are facing scalability challenges due to the explosiveness of sensors in our industries and on our platforms. But industry groups are taking action: MIG, IEEE, MIPI Alliance, INEMI, with new standards, collateral interfaces, methods. We're leveraging aggressive timelines that I think can be applied to IoT. Please come forward. Please participate, so we can at least initially understand how we can close those gaps specifically for IoT. Thank you.
Thank you so much, Ken, for a very engaging presentation. Before I introduce our third and final speaker, I'd like to remind participants, please go ahead and submit your questions. We're receiving some excellent questions that hopefully we can get to all of them at the end of this session. So again, please feel free to submit all your questions as they come up. And with that, I'd like to introduce our final speaker, Ravi Subramaniam. Ravi, over to you.
Okay, great. Thank you. My presentation is going to touch a little bit on what we like to call post-standardization activities. Many industries tackle this in different ways. Through my presentation, I'm going to kind of touch on how some industries adopt these and somewhat of an aspirational view as to how MEMS can benefit from a conformity assessment program. So conformity assessment program has multiple benefits to it. Usually, conformity assessment tends to be standards-based. It allows the industry to identify issues with non-conformances with the products, devices that are under test, have pretty clear, concise descriptions on how products should perform and how they should be tested. A good example that comes to mind is the issues that we had with the Dreamliner batteries. I think Japan Airlines, through one of their reports, clearly indicated that some of those issues were related to inadequate testing prior to deployment. So it becomes extremely important that we have nice, robust, comprehensive testing processes in place, along with any kind of conformity assessment activities, which may include certification. So kind of going through this, multi-vendor solutions always tend to have interoperability issues, and we have seen this through the telecom world, where we work with multiple vendors coming with products that claim to be in compliance with the standard, but we see interoperability issues consistently, and that becomes a deployment nightmare to a point you don't know where to start. Now, vendors obviously, spend a lot of efforts towards testing based on specific buyer implementation. So having standards sort of helps to have a baseline procedure or baseline requirement in place. Buyers and end users are going to continue having their own specific requirements, but having some sort of a baseline standardized testing methods in place helps to reduce some of those costs. Let's go to the next slide. Here I'm kind of touching a little bit from the perspective of a systems integrator versus a manufacturer. So I think Ken had sort of touched on this as a systems integrator. I have highlighted here that the systems integrator acts as the certification driver or plays the role to get more people going towards having standardized and certified sensors prior to deployment. So one of the main issues that we have with certification and testing is it could be a pretty expensive venture to have a testing tools and platforms in place to be able to test particular devices. So having a common platform, a shared resource that can be utilized, like one of the previous speakers, Chuck, had touched on, having those expertise and making sure that everyone's testing to the same standard, utilizing the same methods, same tools, helps to alleviate any confusion in the market. And from a systems integrator standpoint, you also have now have a larger amount of suppliers at your disposal that you can buy from and be ensured that they are going to function as they are supposed to. And from a vendor standpoint, again, as I mentioned, buyers are going to have their own specific testing requirements, but having this baseline really helps with the process, and it also expands your reach, not just nationally but globally. Let's go to the next slide. So a couple of things that we need to have in place in order to have a very successful conformity assessment and certification program. First of all, you need to have your demand driver identified, and in this particular case, I think it would be the systems integrator who would be driving the industry to get certified devices in the market. And obviously, we have talked a lot about standards. We need to have standards in place. And where standards themselves are ambiguous enough that you cannot automatically translate those requirements into testing specifications, then you're going to have some test specifications in place that can be utilized by industry. You also need to have test tools, test labs that can actually perform those analysis, and vendors with products that are implementing those standards. And none of this can be done without actual education and outreach, which IEEE and MIG have been trying to do with many of the numerous activities that the conferences and congresses that we plan. Next slide, please. Now, last year, the U.S. government, the Office of Management and Budget, through one of their documents, OMB 119, recommended that this would be a nice structure to have where certification programs can be built upon. If I were to step through this right from the bottom, we have manufacturers who are designing products based on standards. We then want to be able to utilize test laboratories that can perform testing on those products or systems. And the recommendation is that we work with testing labs that are ISO IEC 17025 accredited. This is a good practice that has been utilized by multiple industries, including the telecom environment, toy safety, the Energy Star program by the DOE. They all utilize this process. Now, there's an additional layer of certification where we work with certification bodies where there would be a legally binding contract with vendors who come through the certification program. And last but not least is the accrediting bodies, and those accrediting bodies need to be certified to 17011. The accrediting bodies go out and actually audit test laboratories to ensure that all test laboratories are performing the work in the same way. And all of this is done with a scheme owner in mind. And if you think of the Energy Star program as an example, the DOE actually acts as the scheme owner, whereby the scheme owner actually holds the Energy Star program label or logo and allows utilization of that for any person who comes through the certification program. Let's go to the next slide. So what is the alternative if we don't decide to do any of these activities, standardization versus conformity assessment? Then we kind of come back to Chuck's very first slide, right? We have vendors or systems integrators trying to do their own thing. There could be conflicting definitions, which in the end is going to create a lot of confusion, lack of understanding in the industry, which makes selling points of MEMS products difficult to see. And if you really think of what comes to mind is the TDMA and CDMA technology. A lot of pundits would say, yeah, CDMA was a far superior technology. However, it just did not get any market traction because it lacked standards. So people were afraid to adopt it. So TDMA, flourished in that process. So having standards kind of helps in that process. Let's go to the next slide, and I'll very quickly summarize my previous speakers as well. So standards are challenging. There's multiple benefits to it, and I've touched on a lot of them. However, there are challenges, and I want to very quickly just touch on the challenges. Participating in standards development activities, there's always going to be IP protection issues, right? What do you protect? What do you expose? Those are always going to come up. and there's going to be competition. So when you standardize things, then you create an environment where you're going to have to compete on efficiency and differentiation, which in a sense really spurs on innovation. So to me, it seems like a benefit. And then there's also the underlying issue of cost and resources. So standards development, as you can see, takes anywhere from, in the case of MEMS, 10, 12 months. It may take more for some cases. So making sure that you dedicate those resources and support for standards development activities becomes somewhat of a challenge. But I think through all the speakers we have seen, standards becomes an integral part of any technology, and it's required for the success of the technology. Back to you, Lloyd.
Excellent, Ravi. Thank you so much. Yeah, that was a very engaging presentation there. So, first question that I'd like to put to the speakers. This one probably would be addressed to Karen. Karen, what has shifted in the market so that the standards are no longer referred to as the S word? How has the MEMS sensor industry changed to adapt this change?
Excellent. I love it. I'm glad that's definitely a question I can answer. Thank you, Lloyd. So what's changed is the folks like the Intels and the Qualcomms of the world, what really, they are demanding that there be performance standards. That's how we were able to get this large ship moving in the right direction, is that the buyers, if you will, of MEMS and sensors are saying, we cannot have 18 different spec sheets for 20 different types of MEMS and sensors for our one product when we have a 6-month time to market horizon. It is, especially in the mobile space, it is a non-starter. We must have standardization. So folks like the STs and the Bosches and the analog devices, they understand. They want to be in that, trillion sensor world. They want to be in every mobile device, in every thing in the Internet of Things, and they understand that they needed to come together. So the timing was right. The infrastructure was there, that being MEMS Industry Group, the forum for that, and it was sort of like the a perfect trifecta of all the things at the right place at the right time. And so we were able to move this creation of standards. There are lots more to do beyond just the IEEE 2700, but I think the timing is right.
Wonderful. Thank you so much, Karen. Let me take another question. This one was potentially targeted towards Chuck. Chuck, one of the questions came through. It starts off, I would think that the major MEMS players are thinking that having unique specs lock in customers. For example, once you design a Bosch accelerometer, it is difficult to swap in a Freescale accelerometer. How do we convince the industry to change this mindset?
Yeah, I think it's a great question. I think, though, the suppliers who think that way are underselling themselves, because actually the players we talk to, for example, we provide performance comparisons to our customers, so the performance of their part will show through anyway. It's just through the lens of our own testing, and each manufacturer brings something unique to the market that they can sell. So I think actually, if they focused on their unique performance rather than data sheets that make seeing those differences hard to see, I think they'll still find a very welcome marketplace for their products.
Thank you very much. Let's step on to another question, another question from our audience. This one I think is probably targeted towards Ken, but others feel free to jump in. How does this standard framework differ from that of All Seen Alliance and OIC, IoT protocol standards. And I think this one came through, Ken, while you were giving your framework presentation.
That's a good question, actually. I'm not extremely familiar with All Seen Alliance, so that actually proposes one of the difficulties in targeting an effort such as standardization towards new or adjacent industries is surveying the landscape with respect to what's currently there, and really I think finding your niche value proposition. So that is something that we are doing right now at the MEMS Executive Congress that MIG hosted in November. Both Chuck and I we co-hosted a table discussion during lunch where we tried to start off with that, which was here's a snapshot of the landscape, and we need to know that landscape not just for consumer but for other industries, and when we look at the standards working group, delivering a spec that becomes the industry standard isn't the only direction that we view being able to take. Sometimes it is just collateral. Sometimes it is literally doing that market or that kind of industry scan or standardization scan, finding that niche, and even providing the results of that scan to MIG members is value that we look to bring. So specifically, not really going to address the difference between All-Seen or OIC, but we certainly see that as a challenge in trying to serve the industry, but obviously not wanting to do redundant work.
Okay, very good. Yeah, we're receiving a bunch of very interesting questions. So again, feel free to continue sending questions. So this is going to be out to the panelists. So for someone who feels that they are apt to respond, please do so. So this is a fairly long one. So it starts off, I clearly see the need of manufacturing and testing standardization, and the panelists are very consistent in their approach. How does today's panelists foresee this simulation at a level of designing stage to play any major role in MEMS as a system and sensors as components in standardization, considering system readiness, system scalability, system integration, and system validation and verification? So that's a long one, but a very detailed one. Would anyone like to take a stab at that one?
Hey, Lloyd, it's Karen. I have a really short answer, and then I'll let the experts expand. We have a saying here at MEMS Industry Group. Our ultimate goal is to design for no test. That is the ultimate goal. May not be feasible in the next few years, but that is an ultimate goal that some of my device manufacturers would like, is to have a design for no test, and with 100% yield. All right, Ken and Chuck, you can now comment.
Okay, this is Chuck. I'll put in a short answer on a different line. I think the ultimate is lots of specs and lots of testing, but right now we're in a stage where even the relatively straightforward standardization isn't there. So we shouldn't let the best be the enemy of the good, if you will. I think small steps can help in the assessments on the system level, and so they're worth doing on their own, even if they aren't the full solution.
Yep, and I'll add from a system standpoint, looking at the devices, a nice end goal is to have accurate models for individual sensor performance. In essence, that's what we try to build off of product data sheets. It's just sometimes in their vagueness, it's very hard to do that without additional testing that Chuck had alluded to. But certainly a valuable effort may be standardizing how those models are created and how you use the models, so that assessing vendors' performance in, let's say, targeted applications with specific algorithms would certainly benefit from those models.
Excellent. It's a very detailed question and a very detailed answer. Now, with 4 minutes, we have quite a number of questions. I'll go through some of the more somewhat challenging ones to the audience. For those questions that I do not get to, we will try to respond to them online or using some other method. But again, thank you so much for all your questions. So, Ravi, there's a couple of questions that comes through for you from a interoperability standpoint. So, one of the questions it starts off: certification can be validated through the registry of which interoperability is addressed, as well as with the metadata. So, I think that's more of posing a point there as opposed to a specific question. Again, just to repeat that, certification can be validated through the registry of which interoperability is addressed, as well as with the metadata. I'm assuming, do you see that as an appropriate or a correct position?
Yeah. So it's always challenging when we talk about certification versus interoperability. Two products that are meet the requirements of the standard may not necessarily be interoperable. So those are some of the challenges that that many industries have seen. So it's yet to be seen through the MEMS activities. That is something that we will have to closely track and see how those things go.
Very good. There's another one. I'll try to run through these in very quick order. How much of the standardization effort around MEMS goes towards software interfaces and APIs?
This is Ken. I can try to speak to that, and that's an area that we've attempted to play a role in recently, and put a good bit of effort into doing that, just to have kind of the trade winds go in a little bit of a different direction, where in consumer at least there was a time that from an API standpoint it was a bit like the Wild West. What we're finding is that that's a space that really the Googles and Microsofts and Apples of the world exist in, and I think are doing a much better job in. It's still fractured, but not as as horribly fractured. And so you kind of have to look at the value in what you're doing, and sometimes move elsewhere in the stack. So we had seen an opportunity there a few years ago, but it was in the end proved to be very very difficult segment to address, mostly because of the directions that the OS vendors are going. Now there is a certain level where that can function maybe a bit lower, and some standardized APIs may be valuable. But certainly where we were targeting in the stack, we quickly found that just was kind of OS vendor turf, and the reward just didn't really seem like it warranted the effort.
Okay, very good. Thank you so much. Well, we're right on the hour now. It's now 12 o'clock Eastern Standard Time. And this concludes this webinar. This is a series of webinars that will take place over the next several months, so please watch this space and check in regularly for the IEEE website for additional webinars on this topic. Again, I'd like to thank each of the speakers and panelists for some great insights and some valuable information. This has been recorded and will be made available on the IEEE SA website. So again, you can check back to view the recording at your leisure, and certainly please free to forward the recordings to other folks that you feel may have an interest. With that being said, I'd like to again thank all the panelists for their participation, and thank all the participants for attending this seminar. This webinar. Thank you so much, and we look forward to speaking to you and others. This concludes the webinar. Thank you very much.